Hey everyone, how are you doing tonight? We're going to be doing section 4.1 in the Statsmatic sequence. This one should teach us a lot about how to create a random sample from a population. And it's going to start by us looking at this question about Taylor Swift. So we have Taylor Swift's concert promoter wants to find out how much fans enjoy the concerts. He will ask fans from 1 to 100, where 100 is the most, how much did you enjoy the concert? The section he wants to survey is 50 seats, 5 rows and 10 columns. The stage runs along the northern edge of the venue where Taylor is pictured. You can see the Taylor right over here, highlighted in yellow. So method 1 is going to be take something called a simple random sample of 10 fans. Explain below the steps you use to obtain the SRS. So let's get some definitions here. First of all, what is a simple random sample? Well, a simple random sample, or SRS, is a selection method where every possible set of n objects has the same probability of being selected. You can imagine, for example, that if you are in a classroom and your classroom has 30 students in it, then if we're saying n equals 5, then every possible set of 5 students will have the same probability of being selected. Very importantly, although in an SRS each individual in the population has the same probability of being selected in the sample, the common error is that an SRS is not defined by that property, that every object has the same probability of being selected in the sample. I always think about that, sometimes in our school we have a backpack search, and sometimes the dean of students will come into the classroom and say, okay, everyone, every 5th student is going to go outside and show me what's in the backpack. And although that is true, every student has the same probability of being selected. What's not true is if 2 students are sitting right next to each other, they're probably not going to be selected for that backpack search. So that every 5th student rule, although this might be a good sample, that every 5th student is not an SRS. Okay, so how do we create a simple random sample? Well, I think there are 3 good methods to take an SRS. The first way is this ID and random numbers. And this is a kind of sampling scheme where we would use technology, or we would use a table of random digits to help us randomly select members of the population. This is actually the one we're going to be using for this sample. So rather than talking a whole lot about it, I'll just go ahead and table that for a few minutes from now. A second option for creating an SRS is to use some kind of a random device. We can use dice or a coin to decide whether a member of the population is going to be in the sample or not. This is going to be done most of the time when we get to the section 2 of chapter 4. We'll be using a random device pretty often. And then the third way of taking an SRS would be just to do the good old names in a hat. Put everybody's name in a hat and draw out as many of those names as you need for your sample. So the method that we're going to be using here is to use the ID and calculator method. So our first step is to label each member of the audience. So we're not going to be too fancy about it. We're just going to give if we imagine all of these little squares down over here, if we imagine them all as seats, well then this person in this seat, this person in this seat, this person in this seat, we're going to have numbers for them. So I'm just going to number them from 1 to 50. Okay, so here's our 1 through 50 And the next step that we're going to do is we're going to use a random method of selecting numbers from 1 to 50. I'm going to say that we're going to select our random numbers from 1 to 50 using technology like our TI-84. So to make your TI-84 give you a set of 50 numbers, we're going to click on Math. We're going to scroll over to Probability using the arrow keys. And then we're going to say Random Int. That's number 5. So I'm just going to click number 5. And our calculator is going to allow us to input what we want for the lowest number possible. That's the lowest integer that I want to be picked is going to be 1. Scroll down, and then we're going to say, well, the highest or the upper digit that I want to be picked is going to be 50. So this says I'm going to get integers between 1 and 50 only. And then this last one I can say I want 5 of them. So when I paste this onto the screen, it's going to say, give me 5 random digits, random integers between 1 and 50. So I'm going to paste it. If your calculator doesn't have that stat wizard that I was showing you just now, you can just type this into your calculator. I'm going to push enter, and then I will get 5 digits. Hopefully we'll have no repeats. This one does have a repeat, so I have the option of using 11, 29, 7, and 31, and then getting one more random digit, or I can just roll the dice one more time and get one more random digit. As it is, I'm going to just click enter one more time, and then I'm just going to use 6. So my random numbers is going to be 11, 29, 7, 31, and 6. And I'm realizing that I was supposed to take 10 fans, so I'm just going to go ahead and put the rest of them. So the next one was 21, 16. I got 11 again, so I'm going to have to find 2 more numbers. And my calculator gave me 5 and 49. I probably could have saved myself a lot of trouble if I just, instead of picking 5 numbers, if I picked 10 numbers, that would have saved me some trouble. But hey, you know, sometimes things happen. It's good to see that there are mistakes that are not, that are not insurmountable. So I have my 10 seats, or my 10 people who are going to be in my sample. Actually, I only have 10 numbers. So the last step here for the SRS is to select the seats that have the same numbers as my random digits and use them as a sample. So in other words, the seats with numbers matching the random digits will be included in the sample. And that's going to be these lucky 10 people. These 10 people are going to be my sample. Okay, so that's taking in SRS. All you need to do is label each member of your population. Usually you're going to use sequential integers. Then you're going to use random digits from your technology. So you're going to select random numbers from 1 to 50 using technology. And I think probably here we're going to say 10 random numbers from 1 to 50 using technology. And then the seats with numbers matching those random digits will be included in our sample. So there's our SRS. That's a good method, or a good basic method that we're going to be using here. So yeah, SRS. Method 2. Method 2 would be to instead randomly choose 2 fans from each horizontal row. Okay, so if we're going to have 2 fans from each horizontal row, what are we going to do? Okay, well, first of all, we need to know this method is not an SRS. If we're picking 2 fans from each row, then it is literally impossible to have all 10 people in the front row be included in the sample, because we have to have 2 people from the second row, etc., etc. So because there are some samples of 10 audience members who will never get picked together, this can't be an SRS. Contrast that with what we just looked at with method 1. Now it is possible, it would have been possible for my calculator to randomly select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would have been very unlikely for that would happen, but that is still a possibility. Whereas in this method, there's going to be no way because we have to only get 2 people from the front row. This method is called a stratified random sample. And for a stratified random sample, you're going to select a set number of n objects from each group or strata. So in other words, if we're going to call each row a group, we're going to also call each group a strata. So let's go ahead and look what are the stratas. So in this setup, we're going to call each row a strata, and here I've colored each strata a different color so we can see what that looks like. And in practice, we're going to take an SRS from every strata. So for the first 10 seats, we're going to go ahead and choose 2. So we'll start off by defining or being clear that each row that we see is going to be a strata. Then we're going to label each seat in row 1 from 1 to 10. Okay, now that we've labeled each seat from 1 to 10, we're going to use technology to select 2 numbers from 1 through 10. Now, as a reminder on our calculator, we're going to click Math, go to Probability, and we'll do a random integer. This time, the low will be 1, and the highest number is going to be 10, and I only need 2 of them, so I'm going to do 2. So let's paste that. Let's get our 2 random digits, and we're going to select 4 and 10. Now that we've selected our 2 seats, or 2 random digits, the seats that are the same as the random digits that we just selected are going to be our sample. And then we're going to repeat this process for the remaining 4 rows. So we're going to label the seat from 1 to 10. We're going to use technology to select 2 random digits, in this case 5 and 5. That's not going to be good because we can't select the same seat twice. So we'll do it again. We'll select 8 and 2. And the seats in the second row that match those 2 digits, 8 and 2, are going to be selected for the sample. I'll go ahead and repeat for the rest of these. And that's our stratified random sample. We're going to break the population into strata, and then we're going to label each strata, and then we're going to use technology to select 2 random numbers from 1 to however many there are in the strata. We're going to say that the seats, in this case, that match the random digits are going to be included in the sample, and then repeat for each strata. So, stratified random sample. Method 3, let's do method 3 now. It's going to be a stratified random sample again, but this time, instead of doing each row as a strata, we're going to use each column from the strata. So I'm just going to copy those directions over. So this is another stratified random sample, but this time we're going to use each column as a strata. Let's label all the columns real quick. Okay, now that every column is numbered from 1 to 5, we're going to use our technology to select 1 random number between 1 and 5. So once again, Math, Probability, number 5. This time my lower is 1, my upper is 5, and I only want 1 number. So let's go ahead and paste that, and we're going to select number 1, number 5, number 5, number 4. Let's go ahead and circle those. So number 1 in the first column, second column, number 5, third column, number 5, fourth column, number 4, and we'll just keep sampling. All right, now I have a full set of samples, each one of these with 10. The next one is going to be a subjective question. Which do you think is better and why? And let me give you a couple of things to think about. In the first method, that was a pretty easy method to do. We just had to do one set of random digits and then select them. Okay, there might be a problem here. I'm taking a look at my sample here, and look at this. I've got 3 people right in front of Taylor Swift in the sample, and then another person who's also right in front of Taylor Swift, but just in the second row. So I don't know, maybe that's going to give me an estimate that's higher than it should be. Okay, taking a look at second method. Okay, I don't have anyone right in front of her or anything like that, but gosh, it's, 2 people in the front row. Maybe this 10 is going to give me or this person way at the edge isn't going to have as good a time as number 4, definitely. Maybe they'll have as good a time as this number 8, blue 8 over here. I don't know. It seems pretty well distributed, I guess. And this one over here, method 3, yeah, look at this. We got 3 people in the very last row. So that's a possibility that this one might have an estimate that is smaller than the true estimate. So which one was best? I don't know. It's really up to you. Okay. Okay, so now number 5, it's time to actually do this, take a look at the actual data. So here is the actual data. Okay, here is what these seats actually rated this concert. And what a surprise, the person right in front of Taylor Swift rated this concert at a 100, while these people in the back corners, 68, 67, 69, 64 over here, the last row, didn't rate it as high as the people in the front row. So let's do a little bit of an overlay then. So in the first sample, this is the SRS sample. The people who were selected, and I'll do this in blue, is the 5th person, 1, 2, 3, 4, 5. The 6th person, the 7th person in the first row. Person number 11. Person number 16, who is right behind that 100. Person number 20. And I think you can see what's going on here. So here are the 10 people selected in the SRS. Let's write down their scores. Okay, we're going to add those numbers together, and we're going to get 845, giving us the average. If I just divide that by 10, that average is going to be 84.5. All right, so that was sample 1. Let's take a look at sample 2 now. Sample 2 were these people, and that corresponds with these scores. And that gives us an average. It gives us a sum of 76.2. So our average is, or 762 is a sum. Our average is going to be 76.2. Okay, that brings us to sample 3. Sample 3, we got these seats, which corresponded with these scores, which means we get a sum of 787 and an average of, what is this, 78.7. Okay, so take a look at our averages here. In sample 1, we got an average enjoyment of 84.5. Sample 2, we got an average of enjoyment of 76.2. And sample 3, an average of 78.7. And you might be saying, hey, well, so what? Okay, well, I'll tell you why so what. Let's take a look at what happens if we plot an entire class worth of data for average enjoyment. What would we get if we did an SRS? We did this in class. Well, we do this in class every year, and this is actually the data that one of my classes came up with. So if we take a look at SRS and we took each group, each table, and they went ahead and they did, no, I think this is actually every person in class did the exact same thing, and they plotted the results. So if we did average enjoyment with an SRS, look at this, we get a single peak distribution, and that peak is right around, oh, I don't know, 70, 78, 79. So it's pretty clear based on this, if this dot plot is going to actually represent what happens, then it looks like the mean average enjoyment is about 78. Okay, that's great. We can tell here, but you know, there's still, what happens if you were that one student who happened to get everybody in the front row? You got an average enjoyment of, say, 90. This person over here. How, if you're in isolation, or if you're actually doing stats, you're only taking one sample. So you don't know where the other samples might have ended up. So your one sample could be this one that's an outlier to this distribution, or perhaps that your one sample is going to be one that's close to the true mean. Maybe it was a 76 or a 77. Okay, so there's still some room for doubt. We're not that confident that our one dot is really close to the actual average enjoyment level. Well, look what happens when we go to the stratification by row. When we stratified by row, we got this huge peak right over here. This one over here, this green dot over here, I think that's just a mistake. But these ones over here, look how close they are to the true mean. Okay, so even if you were unfortunate enough to get this 75 sample, you're still pretty close to the mean. In fact, using stratification by row, you should be very confident that your sample is close to the mean. Okay, I mean, to say nothing of, you know, the odds are you're going to be either in this 79 spike or this 80 spike. So you have a really good chance of being very close to the mean. Definitely much better chance of being close to the mean than if you did an SRS. Now, if we take a look at stratify by column, okay, stratify by column, still the same kind of a thing. We can still say our mean is right about around 80, but this distribution of samples is much more, well, it has much more variability. So again, even though we can tell by taking a look at all of the samples as a whole, if we just had one sample, we shouldn't feel very confident that we are close to the true mean. So if you decide to take a wise sample, stratify by row, then your confidence that your sample is close to the true mean is going to be increased. And you can tell why this worked, because we limited how many people we chose in the first row. We also limited how many people we chose in the last row. In fact, we limited how many people could be chosen in every row. And why that worked in this case is because the single greatest determiner of a person's enjoyment was their row number. So if we limit how many people are in the highest enjoying row, and we limit how many people were in the least highest enjoyment row, then we're less likely to overestimate or underestimate the true mean of the enjoyment level. So once again, we're going to make sure that too many dots or too many of our sample doesn't come from the first row, because we know that the first row is going to really enjoy themselves. We also want to make sure that the last row is not overrepresented in our sample. So we're kind of equalizing our sample in terms of a variable which affects the enjoyment level. So that is our lesson here. So this is what we call other sampling methods day 1. We did a simple random sample on the previous lesson. So now we're looking at stratified random sample, which splits the population into groups that are called strata. And then we take an SRS from each strata. We're going to do cluster samples on the next lesson, so I'm going to ignore those for now. And then we also have a simple random sample as a kind of a review. Let's take a look now at our Check Your Understanding. We've got a factory that runs 24 hours a day, producing wood pencils. What do we got? We've got 3 8-hour shifts, a day shift, an evening shift, and an overnight shift. And in the last stage of manufacturing, the pencils are packages and boxes of 10. So each day a sample of 300 pencils is selected and inspected. So how can we do a stratified sample of 300 pencils? Okay, we're going to explain our choice of strata. So the way I think about it is each strata is going to be one of the 3 shifts, either the day shift, the evening, or the overnight shift. And that's important for us because I'm pretty sure that the day shift is going to produce on average, a higher quality pencil than, say, the overnight shift. So the single variable that makes a difference in the what are we calling this? Quality of the pencil is which shift it's produced from. So what I'm going to say is the confounding variable, and it is a confounding variable, by the way, that affects the pencil quality the most is going to be the shift in which it was produced. We do not want, for example, a sample to have too many pencils from the day shift. In my mind, that would overestimate the quality of the pencils. So here is what we're going to do. We're going to use the pencils produced from each of the 3 shifts as a strata. And underlying all this, if we want to get 300 pencils, that means we're going to take 100 pencils from the day shift, 100 pencils from the evening shift, and 100 pencils from the overnight shift. So we'll start with the day shift. For all the packages produced in the day shift, we're going to number them from 1 to 500. I'm using 500 just as a for example number. We're going to use technology to produce 10 random numbers from 1 to 500. And then the packages with numbers that correspond with the random numbers are going to be included in the sample. Then we're going to use a similar method to select 10 packages from the night shift, and then also 10 packages from the overnight shift. So that means we have 30 packages that are selected for our sample, 10 pencils in each package. 10 times 30 is 300. There's our 300 300 pencils in our sample. Next is going to be a cluster sample of 300 pencils. I don't think I'm going to do a cluster sample because we haven't technically learned that yet. So if you would like to come back to this number 2 and do a cluster sample when we're finished, or after the next day's lesson, or tomorrow's lesson, you can go ahead and get back to this. I will put something in the answer key, but I'm not going to do it in the video. So let's move on to question 3. What's the benefit of using a stratified random sample? So this is the same answer for every stratified sample. Stratified random sample reduces the sample variability that's introduced by the stratification variable, because no one level of that variable is undercovered. We can think about in the Taylor-Swift example, stratified random sample reduces the sampling variability introduced by row, because no one row is undercovered. Okay, so when we're talking about the pencils, therefore, a stratified random sample will reduce the sample variability introduced by the different shifts, because no one shift, either the day shift, the night shift, or the overnight shift, is undercovered in the sample. So that is the end of today's StatsMedic, and I hope you guys have a great evening, and we'll see you for our next lovely lesson. Have a great day.